Okay, welcome back. So we're looking at removing brackets, page 3 of your textbook. Okay, so the example they give us is 3x. Now they use a multiplication symbol. I'm not going to use it. I'm going to use a bracket here, times 4y. But that's the example they open with. Now, the commutative property of multiplication says that it doesn't matter what order we do things in. So instead of having this as 3 times x times 4 times y, we can rearrange the 3 and the 4 to be next to each other. Okay, now this can then simplify and turns into 12. 3 4s is 12. So another way of saying that is that you multiply the numbers first and then you multiply the letters. Okay, now in terms of the letters, they're independent of each other. They're completely different. So the way we write x times y is xy. Okay, now I'm going to set a challenge for you to do another example. Let's multiply minus 5x by 4a squared. Okay, so let's multiply these together and let's go through the steps that I did here. Okay, so pause the video, finish your answer. Okay, and you're back. Welcome back. I hope you got on great. So with minus 5 times x times 4 times a squared. So we multiply, and another thing you do is you think about the signs first. So this minus by plus is minus, 5 4s is 20x a squared. Okay, and that's a kind of a prelude to where we're going here because it's going to get a bit more complicated. Okay. So I'm going to work through all the examples of any section I do. I'm going to make sure to work through the examples, and I'll always use the traditional method shown to you in the book, but I'll also show you alternative methods. Okay, so one of the methods, one of the exercises. Let's call this example 1. And we'll kick off with the binomial 2x take 3 multiplied by the binomial 3x plus 4. Okay, so they use what's called the geometrical area model here. Okay, and in that model it's called a geometrical because it uses geometry. It thinks of it as a 2D question. Okay, now they put the 2x minus 3, so let's say the first factor is placed across the top of your compound rectangle, and the second factor is down the sides. Okay, so we can think of it then as 4 partial products. One, 2, 3, 4. So the first product here, you have 3 2's is 6 and x by x is x squared. This product here will be minus by plus is minus, 3 3's is 9, we get x. This product here involves multiplying 4 by 2x is 8x, and this product here is minus 12. Okay, now they go on to write out all 4 partial products down below, but my suggestion would be that you can skip a line there and say identify these as like terms, and so like terms can be grouped and therefore simplified. So it's 8x take away 9x is minus x. Now this term is unique, so it's on its own. 8x take away 9x is minus x, and then you've got your minus 12 here. Okay, and that's example 1 finished. Other methods. By the way, when we talk about alternative methods, in principle there is no difference between them. What we're doing is distributing multiplication. We're distributing the multiplication of the 2x on everything, and we're distributing the multiplication of the minus 3 on everything. Okay, in this type of binomial, which is two linear binomials, which mean and in a linear binomial you have an x term and a number term. An x term have one x term and one number term. And when you're multiplying two linear binomials, this grouping will always happen. And for that reason, we use FOIL, which is we look at the inners, which is one of the partial products, and we get minus 9x, and we look at the outers, which is the other partial products that get grouped, and they're called cross products. The reason they're called cross products is they're a cross between the x term and a number term, as opposed to the product of the x terms and the product of the number terms. It's kind of likes with likes and likes with likes, whereas the cross products are crossing the types of terms, and you get your minus 9x on the first one, and the I've tried to keep this down in future, but so you get these two terms. Now why would we do that? Because it allows us to do the grouping kind of in our rough work up above, and then we can go straight to the answer here. Okay, so this here is coming out from the firsts, first by first. So just to remind ourselves, it's firsts, lasts, inners, outers. Okay, firsts, lasts, inners, outers. So our inner product, our inner cross product gives us minus 9x, our outer cross product gives us 8x, our firsts give us 6x squared, our grouping of our cross products gives us minus x, and our lasts give us minus 12, the same answer. Okay? The next example involves 2x minus 4 by x squared minus 3x plus 5. Okay, and if we go with our geometry model or geometric model, we will, you see they've swapped, but it doesn't matter, but they have swapped, and they've said, well, the longer one goes along, the second factor goes along the top, but that's because maybe it looks nicer to have 3 along the top. So they're putting x squared negative 3x and 5 along the top, and so in this case their geometry model looks like 6 rectangles, 6 partial products. Okay, and there's a very nice pattern about to arise where we're going to see. Okay, so this comes down the side, this goes across, and it really, you do want, you do want something consistency in your steps. So I think we should always put this one down the bottom, down the left, and put this one along the top. Okay, let's get our partial products. We've 2x by x squared is 2x cubed. The x rises that power. We have minus 4x squared here. We have, and let me point out where they're coming from. It's sign, number, letters. Sign, minus by minus, plus number, letters. Sign is positive. It's no harm in being explicit about it, meaning put it in even though it's understood. Number, letter. Sign, there are number, there's no letters. Now let's look for like products. So there's like partial products. So there's x squareds and there's x's. And this is what happens. You get the kind of extremes, or the number by the number, and the highest power of the variable terms kind of not grouping with others, but these are grouped. So we go ahead and group them. We can group them here on the fly. So we're getting 2x cubed minus 10x squared, because minus 4 of something and minus 6 of it is minus 10 of it. We're getting plus 22x from adding them, and you're getting negative 20. Okay? Now, their FOIL only works is only for binomial times a binomial. And indeed, it's not just that, it's for a linear binomial by a linear binomial. Okay, so we're not going to use FOIL, but I am going to give you an alternative called place value. Okay, and the place value method is called a place value method because when we write a polynomial in X, we can write things like this. Let's go 2x to the 6 plus 3x to the 5 plus 4x to the 4, 2, 3, 4, 5x to the 3, etc. Okay, plus 6x to the 2 plus 7. Each one of these is a monomial term, but together they form a polynomial. Okay, and the powers of x go from 0, the powers of x go from 0 to 1 to 2 to 3. Well, guess what? How many days are in a year? 365 days in a year. Well, that's the exact same as our number system. So if we're able to multiply using place value as we did in primary school without calculators, we can multiply algebra. Okay, so let's go ahead and do this question again, except it's 1, negative 3, 5, because we have an x squared column, an x column, and a number column. And by the way, you can say, well, I know then I'm going to have an x cubed column in a little bit for here. And we're multiplying it by 2, which goes in the x column, and negative 4, which goes in the number column. Multiply them together, we get minus 20. Multiply them together, we get 12. Multiply them together, we get minus 4. Okay, now 0 goes here because this is a next term by a number term. So we don't get any pure numbers from it. We get 10, negative 6, and 2, which has jumped out into the x cubed. And we get 2x cubed from here. So I'm doing something here now. I'm repopulating the variable, which is x. Bringing the x back again, because while we understood the place values, we have to kind of explicitly state it at the end in our answer. So we've minus 4 minus 6 is minus 10x squared. We have plus 22x, and we take away 20. And as you see, we get the same answer, and we didn't do anything different. We're still distributing multiplication. It's still the same maths. It just looks a little bit different. It's a variation. So we're always going to talk about variations and alternatives. This is what they go on and on about in the specification and in the marking scheme. Any valid variation or alternative has to be sized up, and its strategy considered. Is it faster or slower? Is it more prone to forgetting its method? Do you understand it? And I would say to you, if you understand a method and you think it's faster, then go with it. But we'll also do every question in the book with the original traditional textbook method, and there's an argument as to what's the best way of doing things, but I'm going to make sure that you can anchor yourself, and we'll stick with, I'll always do the examples from the book in future with just the way they do, the way it's done in the book first. Okay, I think some of you would like that. Alright. We maybe just put it into practice for the first few even numbered questions that are relevant to what we're doing here now. Okay, so let's do number 21 using the geometric method. So number 21 here has 2x and 4 down the side, and it has 2x squared minus x minus 3 along the top. You're getting 4x to the 3. Now I'm thinking this is kind of heavy work for me. I'm calculating all sorts of stuff that I don't have to calculate, but anyway, minus 2x squared minus 6x, and I'm multiplying across here by 4. Okay, I'm grouping, and we're going with 4x cubed plus 6x squared minus 10x minus 12. Okay, now let's do the same question using place value. So remember your names. Names are very important. Name your method. So the geometrical method, or the rectangle method. Now we'll do the place value method. Two, negative 1, negative 3, multiplied by 2, 4, negative 12, negative 4, 8, 0, always 0, we say Oreo, don't we? Negative 6, negative 2, 4, and our answer populated with x's is 4x cubed plus 6x squared minus 10x negative 12. Hopefully the same. Yes, it is. And we'll use both. We'll do number 16, so it's going to be x minus 5 along the top. If we're going with the convention that the one on the left goes down the side, of course it'll be the same answer because multiplication is commutative, giving us 2x squared minus 10x minus 3x plus 15. They're like terms, 2x squared minus 13x plus 15. We'll do FOIL with them because we can, and FOIL is really fast, and it's probably the best way for a binomial by a binomial. Okay, so we get minus 3x and minus 10x, and we get first by first for this one, 2x squared. We group them to minus 13x, and they're kind of pre-grouped. We don't have to kind of, here we might forget this, but they're pre-grouped for us because we know we're going to be grouping them. And finally we've got plus 15 here and here. Okay, so I'd say to you, maybe work through the rest of that, and that's just one quick. I'm going to give you a video for every section so that you can work independently and go back over second year's material. Alright, see you in the next one.